So this is up on your Canvas. I've tried to put your lab committees. Remember, you need to do one during the term to cover your lab setup points. That goes into your lab. You can do up to 5 more to get an extra 100 points. Each one you come to is 20 points after your first 100. Okay, they will be on the board up here, and they will also be on your Canvas so you can look at them at home. It'll also have a little section here that says, I will not be here after school these days, so that you can plan so you don't say, I'm going to stay and get help, and then I'm not here. Okay, so I'll put those up there, and then up here I'll also put the next week, so you'll know what's going on. Okay, today we're going to do solution stoichiometry, and we're going to do Kool-Aid lab. So as we're doing this, we're going to be doing some notes first up. So if you get your notes out, you should be starting today sapling 7.3. So hopefully you've been working on sapling, and if you have any questions, you're coming in, so you don't wait till the last minute and try and cram it all down your throat, right? Make sure if you're not understanding stuff that you're coming in and get help. Don't just think it'll finally come, and it won't, okay? So just come in and get some help. I'm here for you. All you have to do is come. We'll get you where you need to be. Okay, so we're going to talk about some solution stoichiometry. These problems are a little bit bigger than what I gave you space, and I'm sorry. So if you want to pull out a piece of paper and write on the piece of paper, you're more than welcome to do that. But I didn't give you quite enough room. Okay? So what we're talking about when we talk about stoichiometry is we're working with what? When we did stoichiometry before, what were we working with? A balanced equation, right? And we're moving from moles of something to moles of something new, or grams of something to grams of something new. Okay? Same thing happens with solutions. We can do the same thing with solutions. Remember that we've got the volume in the mole map that we've added at STP. It's 22.4 liters. Remember, we also can use volume when we have molarity. Who remembers what the equation for molarity is? Moles over liters. So molarity, molitary, molarity, molitary, molarity, molitary, moles per liter. Okay, remember I told you there's going to be another one later that I'll give you a little help with that too. But they're all M's. They were not very excited about that. So this looks really complicated, but we've done this stoichiometry math before when we're going from grams to moles, and then we usually go back to grams of something else. But we can go to liters. But to go from moles of one thing in the red to moles of something else in the blue, I have to have a balanced equation. Okay, so that's a big thing. We learned last time about an equation that was C1V1 equals C2V2. That was a dilution equation. That only works if I've got the same compound. Okay, because a lot of times you'll want to try and use that in what we're going into right now, but they're different compounds, and because it's different compounds, I've got to have an equation that's balanced. Okay, if it's the same compound and I'm just diluting it, that's why it's called a dilution equation, I can use a C1V1 equals C2V2. Okay, so just as a reminder, if I'm going from volume or using molarity and I'm going from moles of one thing to another, that center part, I have to use a balanced equation. Okay, to go from moles of one thing to moles of another, I have to use a balanced equation, not the C1V1 equals C2V2. So let's try our first one. So here's our first equation. Again, I like to pull things out, know what I have, circle it, whatever you want to do. So how many milliliters? I'm looking for milliliters of HCl. I have this concentration of HCl. So these two are hooked together, the same compound. Okay? Would need to be reacted exactly with 20 grams of NaOH. Throwing my pen, sorry, caught my dress. All right, so we need to write a balanced equation first. So then I say, okay, I have HCl and NaOH. So here's my reactants, HCl plus NaOH. And they're going to give me something. Who remembers how to write the other side of the equation? What? It's a double displacement. It's actually a specialized double displacement, which is an acid and a base because of the H and the OH. Okay, do you remember how we change partners? Oi, right? Outsides, insides. So our outsides are H and OH, so it's going to make water. And our insides are Na and Cl. Na has a +1, Cl has a -1. Always write your positive first. And since they're all +1 or -1, they just switch partners. I don't have to worry about the coefficients. They're all going to be 1. Right? I didn't need to change anything because it was just Switching partners, no big deal. So then what I do is I like to do underneath this, I like to say, oh, I have 6.00 molar, and I want to find out how many milliliters. Over here I have 20.0 grams. That just helps me organize my stuff so I don't lose it. So I say, okay, how can I use my stoichiometry to figure out how many milliliters? Because molarity, remember, is moles divided by liters. So I don't have enough information to change that 6 molar concentration into milliliters yet. I need to know how many moles I need. So I can change these grams into moles, and then I can go from moles to moles, right? So since I'm working with grams, I'm going to add up sodium from the periodic table, and oxygen from the periodic table, and hydrogen from the periodic table. And I'm going to get a number. I think it's like 39.997. Thank you. Grams in a mole of sodium hydroxide. So then I can do the thing we did in October, where we just take the 20.0 grams and we change it into moles. So divide it by 39.997 grams, and 1 mole of sodium hydroxide would go on the top. Grams would go out, and we would get how many moles of sodium hydroxide? If you haven't got a calculator, I've got some up here. You're more than welcome to borrow. You're going to need a calculator out today. Might as well get it out. Practice this. 0.500, and that is moles of NaOH, right? At this point, since we want to go from moles of NaOH to moles of HCl, this is where I use my coefficients. So I've underlined them in red, and we just set up, factor label again, 1 mole of NaOH, because I want to get rid of it, goes on the bottom, goes to 1 mole of HCl. Well, it's a 1-to-1 relationship here, so it's still just going to give me 0.500 moles of HCl. Everybody okay with that? If I had different numbers, that it would change it. Now I've got moles of HCl, and I remember back that, remember, molarity equals moles divided by liters, and they want to find milliliters, so if I find liters, I can find milliliters. So molarity and liters are going to trade places here. So liters are going to equal moles divided by molarity. I've got my moles, 0.500 moles, divided by my molarity up there, 6.00 molar, remembering that molar is moles divided by liters. The moles will cancel out. 1 over liters is liters. So we're going to get liters. So let me plug that through for me. Give me 3 sig figs. 0, 8, 3, one more. 3. Okay, that's liters. So then I'm just going to get it out of liters. In 1 liter, there are 1,000 milliliters, right? So that would be moving the decimal 3 places, so it's 83.3 milliliters, but I can't stop there. When I'm doing this, I'm going to say 83 milliliters of what? It's of the 6.00 molar let's see, of course my thing doesn't work down there in the corner, HCl. That's the full answer. You've got to tell me how many milliliters of what. Okay? Questions on what I did? We okay? We okay to go forward? I know some of you are still writing, so I don't want to go forward if you're not ready. Okay, we got another problem coming up. Same kind of thing going on. Again, we've got how many milliliters, so it wants to find milliliters of this. So these two are tied together. Solution will react exactly with, here I've got milliliters, but this is tied to this molarity. Yes, ma'am. Times it by 1,000. times it by 1,000. Yep. Okay, so we're back here. First step, since I know it's a stoichiometry, I've got moles of something, I've got something, and I want something else, so I'm going to have a balanced equation. So starting with my barium hydroxide and adding to it hydrochloric acid, what am I going to get on the other side? Remember, OI, outsides and insides go together, but I got to watch the charges this time because I've got two OHs, so that tells me that barium's going to be a +2, right? So it's going to mess with it a little bit. So if barium's a +2, what is the charge on chlorine? Because those are my outsides. -1. So I'm going to need 2 chlorines to go to balance it. Plus I've got H and OH again, which makes always water. Okay, is it balanced? Okay, what do I need to do to balance it? I need 2 oxygen, so what do I need to do? 2 in the water, okay, and what else needs to be balanced? 2 on the HCl because I need 4 hydrogens and I need 2 chlorines, right? Is it balanced now? Okay, so now I've got a balanced equation that I can work with. Now I'm going to put what I have underneath it. So I'm going to do that in green. So I've got, for barium hydroxide, I want to figure out the milliliters, but I do have it 0.225 molar. Underneath the hydrochloric acid, I've got 30.0 milliliters, and I've got 0.190 molarity. Okay, which one can I use to figure out moles? Thank you. I was going to go down and get it, but that's awesome. Okay, which one can I use to find out moles? The hydrochloric acid. So I'm going to be using on that one, molarity equals moles divided by liters, right? So I want to be able to find out moles. So moles is going to be molarity times liters. So I'm going to have to get the milliliters into liters first. So I'm going to take that 30.0 milliliters, and in 1 liter, there's 1,000 milliliters. Milliliters will cancel, and I'll be left with, so move it 3 places, 0.030 liters. Is everybody okay with that? Then I just plug in. So up here in this equation, I'm plugging in molarity, which is 0.190 molar, and I'm timesing it by 0.030 liters. And how many moles does that give me? Okay, 0.0057, give me one more. 0. Okay, moles, and that was moles of HCl, right? Everybody following so far? If I'm going too fast, tell me slow down. Okay, now at this point, this is where we're going to go to our ratios. Okay, because we want to change from moles of one thing to moles of something new. So we've got HCl, we want to get rid of HCl, so on the bottom I'm going to put 2 moles HCl on the bottom, and we want to go to barium hydroxide, so we put 1 mole of barium hydroxide on the top. Moles of HCl will cancel out, and we divide that by 2, the 0.0057 by 2, and we should end up with like 0.0028. Okay, 0.00285. Okay, moles of barium hydroxide. Well, I'm still not where I need to be, right? Because they wanted milliliters. Well, I've got molarity again. So this time in molarity, I'm solving for the liters, right? Which is on the bottom. So I'm going to take liters is equal to moles divided by molarity. So I solve for liters. I'm going to plug in what I have. So I have moles, 0.00285 moles. I'm going to divide by molarity, which is 0.225 molar. This will give me liters. What have we got? Zero, 1, 2, 6. Do I have a second? I forget to ask for seconds. Okay, Make sure you yell at me if you don't agree with it so we can stop. So they want milliliters. I've got liters, so I'm going to change that by saying, okay, in 1 liter, there are 1,000 milliliters. My liters cancel. Times this by 1,000, which is moving 3 places. I get 12.6 milliliters. How do I finish that? That's not quite finished. What do I say about it? Of 0.225 molar barium hydroxide. Yes? So this divided by this? Okay. You got that? You got that? Yeah, so let's try it again. Just put it in 0.00285 and then divide it by 0.225 and see if you can get it this time. Did you get it? No, we want you to make sure you get it. We don't want to see what you're doing.
Is that wrong?
0.00285. That's what you did. That is really weird. 0.00285 divided by 0.225.
Oh, I said 255.
Okay, all right, there we go.
Sorry.
No, you're good. We needed to figure it out so you don't get frustrated. Okay, so everybody okay so far? We're getting this. It's not too hard. It's just putting together a couple things we've already learned. Okay, we got another problem coming up then. Last one. This one, we've got stomach acid is at essentially 0.1 molar HCl. So, okay, I've got this, 0.10 molar. So they already gave me the equation. An active ingredient found in a number of antacids is calcium carbonate, chalk. Okay, calculate the number of grams, so question mark, grams, needed to exactly react with 250 milliliters of stomach acid. And then it says equation, balance. Oh, it's not balanced? What do I need to do to balance it? Because I have balanced equation. 2 in front of the HCl? Is that it? I heard that's it from the rest of you. Okay, we're going to go with it then. Everybody's okay with that? Okay, so 1 Ca, 1 Ca, 1 carbon, 1 carbon, 3 oxygens, 1, 2, 3 oxygens, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. We're good. Okay, just making sure. All right, so which one can I make into moles so I can change it from one thing to another? Hydrochloric acid. So I'm going to have to change that 250.0 milliliters into liters. So divide it by 1,000, times it by 1 liter. Milliliters go out, and we end up with 0.250 liters. Everybody okay with that? Okay, what was molarity again? Molarity equals moles divided by liter. And I'm trying to find what here? Moles. So I'm going to take moles equal to molarity times liters, right? So here's my liters. If I times that by my molarity, then I'll end up with moles. Yes? Okay, so what do I get for moles? Okay, so now I've got moles. Now I'm going to come back up to the equation, and I already used red, so we're going to have to use green here. Come up to the equation, we get a ratio, so we can go from moles of something to moles of something new. What do I put on the bottom? Good, 2 moles of HCl. What do I put on top? What I'm trying to get to, right? Calcium carbonate. Okay, at this point, moles cancel. So we should end up with 0.0125, is that right? And that's moles of calcium carbonate. What was I trying to find? Grams of calcium carbonate. That means I need to take a minute and go calcium from the periodic table is 40.078. Carbon is 12.011. Oxygen, I need 3 of them at 15.999. And I get a total of 100 point something or 101, something like that. 0.86 grams per mole. So then I'm going to take this 0.0125 moles of calcium carbonate, and I'm going to say in 1 mole of calcium carbonate, there are 100.086 grams of calcium carbonate. Cancel out moles, times that through, and I'm going to get how many grams do I need to put in to neutralize that? 1.25. Done. So the only time that I have to add so many milliliters of a certain molarity is if it is of a molarity. If it's just grams, I just need to say this many grams is what you need to add, and it's neutralized. Done. Okay, any questions? You okay with this? Yes, ma'am. We added this up right here, and that right there is where we got that. Okay, so I think you can do it? Doing okay? All right, so what we're going to do is we're going to go to our Kool-Aid lab. So we need to have you working in pairs or truddies. So it looks like we have a truddy, a threesome right there. What I need you to do is within 4 of you, so 2 groups, you get 1 thing of Kool-Aid, okay? Or Tang, or what Country Time, whatever you choose as that group. What you're going to do is you're going to take a scale for your group of 4. These scales work to weigh the water. So there's one point at which you need to weigh the water. So if you don't grab the scales or these scales are gone, you're going to have to go to a group that does have it just to weigh your water. Okay? These little ones just don't have enough guts. I don't know about this one. I didn't have anybody tell me that this one couldn't weigh it, so I don't know if it does or not. You'll have to try. So what you're going to do is grab one of those, grab the lid too, so it's just with it. That way you can put it down in if you need to. The spoons are just for getting the solids Kool-Aid out. They're not for stirring. Okay? Over here, you'll pick up a bathroom cup. Everybody in your group needs a bathroom cup. Unless you're diabetic, please don't do this because it's really high in sugar. Or what my kids would say, it's high in diabetes. So grab one of these, grab a stirrer, and then you're going to take a mark, and between you and your partner, you're going to mark the same place on the cup, about 1 centimeter down from the top. And it's just a little bit below the rim, so you don't fill it all the way up to the top, but you fill to the same place every time. Okay? So there's some markers up here. You're going to take that. So one person could come up here and get one for both of you and get 2 stir sticks. What then you're going to do is you're going to fill it up or weigh it without the water. You're going to fill it up. You only have to do 1 with the water in it. Fill it up to the water line. Weigh it again. Then you can drink that or you can chuck it. I don't care which. And then what you're going to do is you're going to put each of these, for each of you, on the scale at a time, and you're going to weigh out what it is for 1. Then you're going to fill it up with water to the line for both of you, stir it, and you've got to decide, do all the things it tells you to observe. So what did it look like? How did it smell? How did it taste? Rating, 10 being it was how Kool-Aid or this should taste, versus 0, oh, not even close. Okay, I gave you 3 different ones that you have to do, 1, 2, and 3. 3 different molarities. None of them are the correct one. Okay, I'm going to tell you that right away. None of them are the correct one. So you're going to have to then decide between you and your partner, once you get 1, 2, and 3 done, okay, which one was closest to it? And which way do we need to go from there? So on the next page, on 4, 5, and 6, start with 1 at a time, go to 4, and say, okay, what do you think? Should we add more to this one or less to this one? You're going to figure out the molarity if you add more grams or less grams. Okay, you're going to figure out what the molarity is, show me how you calculated it, give me the molarity. Then you're going to try it and see what happens. When you try it, did you come close? Do you need more? Do you need less? Go back and do another one. Do another one. You have 6 trials total, and you've got to find that perfect Kool-Aid. But both of you have to agree. So if one likes it really sugary and the other one doesn't like it so sugary, you've got to come to a nice happy medium. Okay? Now, once you're all done, the cups go in the garbage. If it's so nasty you can't stand it and you really don't want to drink the rest of it, the sink's right there. Go dump it out, rinse it out. Okay? I've got ice water on the back tables so that you can use that. And then after you're done, the post-lab questions will tell you, and it might be a nice thing to do as you go along, number 2 in the post-lab question, what was wrong with each of the other solutions you made? This one was too dilute, this one was way too concentrated, this one, whatever you say. I would fill that in as I did it because it would be easier because it's fresh in your brain. But the others you can finish later. Let's see. Is there anything you have to come clear with me and get your pre-lab stamp before you do any of this. And number 3 was your most concentrated, right? 0.7 molar. You may not use more than the 0.7 molar told you you could use as far as Kool-Aid, because that's extremely concentrated. Okay? I think that's all the rules. All right, let's go ahead, and if you need a stamp, come on up. And